So now let's talk about exceptions. Sometimes, even though an operation or a piece of code is correct, there are conditions in which something may go wrong. For example, if we're converting user input from string to int, the user could accidentally type a letter in place of a digit, making it impossible for us to convert a value into a number. When dividing number, we may know in advance whether we're attempting to division by zero. When operating a file, it could be missing or corrupted. When an error is detected during execution, it's called an exception. Exceptions are not necessarily lethal. In fact, we've seen that stop iteration is deeply integrated in the Python generator and iterator mechanisms. Normally, though, if you don't take the necessary precautions, an exception will cause your application to break. Sometimes this is the desired behavior, but in other cases we want to prevent and control problems such as this. Let's see an example of a few exceptions. And so let's create a new folder called exceptions. And inside I'll create a new file called first dot example and dot py. Okay. Inside we can say something like gen it's equal m for n in range of 2. Next we can say next gen like this, and also like this, and also like this. We can execute it. Okay, we're running Python terminal. Okay, you will see here that we got a stop iteration exception. Okay, here we will got 0, and here we've got 1. By the third one, we've got these exceptions. At the same time, if we print undefined variable like print undefined name like this, what do you expect? So something like this. Undefined name is not defined. Okay. The same way, if we go create a list, my list equal to 1 to 3, and then we will say my list I will got the 5th position. What you will got will be an exception, specifically an index error exception, list index out of a range. I've got many examples. You can create a dictionary. I mean by dict. You can say A equal to A, B equal to V. You can say my dict. I want a Z here, and what you will got will be okay. KRZ, okay, line 11. when we're talking about numbers, the classic error of base mistake is dividing by 1. For example, number equal to 1 divided by 0. And what you will get here is a zero division error, division by 0. Okay, to handle an exception, Python gives you the try statement. When you enter the try closure, Python will cut out for one or more different type of exceptions according to how you instruct it. And if they are right, it will allow you to react. The try statement is composed of the try closure, which open the statement, one or more except closure, or optional, that define what to do when an exception is caught, and else close, optional also, which is executed when the try closure is exited without any exception raised, and finally closure optional also, whose code is executed regardless of whatever happened in the other closures. The final close is typically used to clean up resources we saw this in chapter 7, file and data persistence, when we were opening file without using a context manager. So let's see try cut structure. We'll create a new file called try.syntax.py, and inside I will see def try underscore syntax numerator denominator try print something like f in the try block, numerator and denominator. Okay, result equal numerator and divided by denominator, and exception except 0, not like this, 0, okay, 0 division error as SDE, print ZDE, else print and the result is result return result. Finally print exiting, okay. So let's print here try syntax and 12,4, and of course I will try to cut with division by 0 again, 11 and 0. Let's execute it. Okay, let's see. Is not first example is exception try dot syntax.py. Okay. Dot exceptions. Okay. You will got here. I try to block 12 divided by 4. The result is 3 exiting. And then I try to block 11 by 0 and divided by 0, division by 0, division by 0 error, exiting, and none. And the result. If you want to handle multiple exceptions differently, you can just add more except clauses like this. You can write something like this, okay? And try dot except. You will see here exception 1. Okay. And also you can say exception 2, exception 3. Okay. Exception 4. Of course, you here will react to exception 2 and 4 and 3, and you here will react to exception 1. And here you will react to exception 4. You will put here some code. Okay, this is a structure. If you wanna catch multiple exceptions differently. Okay. One important thing to know is that every Python exception derives from base exception, but your custom exception should never inherit it from it. And the reason is because handling much such an exception will also trap system exiting exceptions such as system exit and keyboard interrupt, which derive from base exception, and this could lead to several issues. Before we talk about profiling, let me show you the conventional use of exception, just to give you something to help you expand your views on them. They are not just simply errors. So let's create a new file called for.loop.py. For.loop.py. Inside you will see something like n equals 100, font equal false. Then I will iterate 8 in a range of n, something normal to there. Okay, this equal is unnecessary here. If font break, okay, I will see another 4 inside, b range in n. And again, if font break, another iteration inside. In this case, we will try with z in range if font will break. In this case, not. Just you will see if 42 times a plus 17 times b plus z will be equal to strictly equal to 1596, found equal true, print A B C. This code is quite a common idiom if you deal with numbers. You have to iterate over a few nested ranges and look for a particular combination of A, B, and C that satisfies a condition. In this example, condition is a trivial linear equation, but imagine something much cooler than that. What bugs me if it's having to check whether the solution have been found at the beginning of each loop. In order to break out of them as fast as we can when it is, the breakout logic interferes with the rest of the code, and I don't like it. So I came up with a different solution for this. Take a look at it and see whether you can adapt it to other cases too. Let's compare here. You can see here define first a class which is exit loop exception, and exception it will receive and pass. Okay, and then you can use a trace structure statement. Say it's something like we have got here. Okay, but in this case, instead of printing, you will write an error exit loop exception, and you will pass A, B, and Z. Okay, and the exception will be cut here. Exit loop exception as L. You will print it here L. Okay, so we can there we can execute it. This file is called for.loop.py. Okay, I will see the combination of number that meets this condition is 79, 99, and 95. Can you see how much more elegant is it? Now the breakout logic is entirely handled with a simple exception whose name even hints its purpose. As soon as the result is found, we raise it, and immediately the control is given to the except clause that handles it. This is food for thought. This example entirely shows you how to write your own exceptions or read up on the official documentation to dive into the beautiful details of this subject.